Welcome back, everyone. Today, we're taking a deep dive into the world of interactive textbooks.
Those textbooks where you can actually experiment with the stuff you're learning about.
Exactly. Our source material comes from a 4-day workshop, actually, held in Singapore back in November 2016.
Yeah, a bunch of educators got together to learn how to build these really cool dynamic learning tools.
I mean, imagine, you're trying to learn physics.
Right.
Instead of just reading about, a soccer ball hitting a goalpost, you could actually control a simulation of it.
Oh, that's good.
You could, change the angle, the force, all that, and see how it affects the trajectory.
It's real time.
Yeah.
It's pretty amazing.
That's exactly the kind of stuff these educators were learning to create.
And this deep dive, is perfect for anyone who's curious about the future of education or the power of interactive learning.
Or even just how to build a simple physics simulation, if you're into that sort of thing.
Yeah, for sure.
Okay, so let's rewind back to day one of this workshop. It was held at this place called EduLab at AST.
Which is part of the Academy of Singapore Teachers.
Right. And it was organized by Technologies for Learning.
Part of the Ministry of Education in Singapore.
And they had these professors leading the workshops from the University of Murcia in Spain and Davidson College in the USA.
Quite the international group.
It was. And this was for, all levels of math and physics teachers.
Yeah.
From primary school all the way up to, junior college.
Wow, so a pretty wide range of experience.
Yeah. So day one, it was all about getting started with this tool called EjsS.
That stands for Easy Java JavaScript Simulations, by the way.
Ah, okay. So the morning session, they focused on building a really basic simulation.
Just starting with, simple object movement. Think of it like learning a new language.
Okay.
But instead of words, you're using variables to describe how objects behave.
So instead of saying move the ball to the right, you'd adjust a variable for horizontal velocity.
Exactly. And you get instant feedback with the GSS. You change a variable, and bam, you see how it affects the simulation right away.
It's like learning by doing, by, experimenting.
Yeah. Hands-on learning at its best.
And they weren't just moving shapes around either. They learned how to add, trails to track the object's path.
Oh, and sliders to control variables in real time.
And even checkboxes.
Yeah.
To toggle different parts of the simulation on and off.
Not like a light switch.
Yeah, exactly.
They even figured out how to put in pictures, like a soccer ball image, to make it all look more, real.
So they were building, interactive diagrams that could react to user input.
Pretty much. It's like bringing diagrams to life.
That's really cool.
Yeah, and in the afternoon, they switched gears a bit. They started exploring existing simulations on this platform called OSP at SG.
OSP at SG.
Yeah, it stands for Open Source Physics at Singapore.
Oh, okay.
It's got this huge library of simulations that teachers can use directly or adapt to fit their own lessons.
So they don't always have to start from scratch.
Nope. It's a great example of how open educational resources can make everyone's lives easier.
OSP at SG sounds like a pretty amazing resource.
Oh, it is. And they even got to see a really cool example in EPUB about modeling wealth inequality.
Wealth inequality.
Yeah. It shows how interactive stuff can make even complex ideas, easier to understand.
It makes sense when you think about it. If you can visualize it, you can grasp it better.
Exactly. So day 2 of the workshop, it was all about, packaging and platforms.
Packaging and platforms. Okay.
Yeah, so in the morning, they focused on the bigger picture, the whole ecosystem that supports these interactive textbooks.
Gotcha.
They talked about open source physics.
OSP, right?
Yep, OSP.
Mm-hmm.
And EjsS, of course.
Which we already talked about. That's
Okay.
the tool they use to actually create the simulations.
Exactly. And then there's this thing called Compadre.
Compadre? Now that's a new one. What's that all about?
Think of it like a giant digital library.
Okay.
But instead of books, it's filled with all these interactive learning tools.
Simulations, visualizations, that kind of thing.
All that. Teachers can find stuff, share stuff, organize stuff.
That's amazing. Like a one-stop shop for interactive learning resources.
Exactly. And within Compadre, there are these things called filing cabinets.
Filing cabinets, for papers.
Kind of. But in this case, they're like curated lists of educational content.
So a teacher could create a collection of resources on, say, Newtonian mechanics and share it with their students.
Or with other teachers. It's a great way to make sure everyone has access to the good stuff.
I love that idea. It's like collaboration on a global scale.
It is. Okay, so now we've got all these great simulations, right? But how do they actually get to the students?
Good point. How do they get from the computer screen to, a textbook or something?
Well, they learned about a bunch of different ways to deploy these simulations. Web servers, for one.
Okay, so if a simulation needs a lot of processing power, or it's going to be used by a lot of people at the same time, a web server would make sense.
Right. And then there are EjsS readers.
Readers. Like for books.
Yeah, kinda. They're like standalone applications that let you run simulations offline.
So even if you don't have internet access, you can still use them.
Exactly.
Yeah,
Super useful for schools that might not have the best internet connection.
makes sense. What about EPUB 3? I know that's the standard format for digital books, right?
You got it. They were learning how to package EjsS models into EPUBs so they could be part of a digital textbook.
That's cool, like having a textbook that comes alive with simulations and interactive elements.
Exactly. And in the afternoon of day 2, that's exactly what they focus on, packaging those EjsS models into EPUBs.
I bet that got a little technical, huh?
A bit.
Yeah.
You need to understand some basic HTML, CSS, and JavaScript.
Yeah, that might be a hurdle for some teachers.
Maybe, but the EjsS manual actually lays it all out pretty clearly, step by step.
So even if you're not a coding whiz, you can still figure it out.
Totally. And the look on their faces when they were able to download, open, and interact with their own EPUB creations priceless.
I can imagine. It's like holding a digital textbook that comes alive in your hands.
It is. Okay, so now we're ready to dive even deeper into the heart of EjsS itself.
Day 3, bring it on.
All right, so day 3 was all about mastering the art of EjsS model building, like really getting under the hood.
I like it, getting our hands dirty.
Yeah. The morning session was a deep dive into the anatomy of an EjsS model.
So like understanding how all the different parts work together to create the simulation.
Exactly. They explored all the different tabs within the software. Each one has a specific purpose.
Okay, so walk me through it. What are these tabs?
Well, there's the evolution tab. That's where you define the equations that control how the simulation behaves.
So it's like writing the rules of the game, right? Rules that determine how things change over time.
Exactly. Then there's the initialization tab where you set the initial conditions for the simulation.
Where everything starts out.
Yep. You set the starting values for all the variables. Like if you're simulating a bouncing ball, you'd set its initial position, velocity, that kind of thing.
Makes sense. So you're setting the stage for the simulation to play out.
Exactly. And then there are these things called fixed relations.
Fixed relations. What are those?
They're equations that define relationships between variables. It's like saying if this variable changes, then this other variable must change in this specific way.
It's about establishing those connections, those dependencies between different parts of the simulation.
Right. And then there are custom functions.
Custom functions. So that's where they can add their own code to make the simulation do something unique.
Exactly. It's like having a toolbox with all the standard tools, and then you can add your own custom tools to do even more.
That's cool. It gives you so much flexibility to create something truly unique.
Exactly. Then there's the ODE editor.
ODE. What does that stand for?
Ordinary differential equations.
Differential equations. Okay, now we're getting into some serious math territory.
I know, right? But it's actually not as scary as it sounds.
So what are they in a nutshell?
Think of them as equations that describe how things change over time.
Like the speed of a falling object. It changes over time because of gravity.
Exactly. A differential equation would describe that change mathematically. And in the ODE editor, that's where you define those equations for your simulation.
So you're basically telling the simulation how to evolve over time.
You got it. Then there's the prelim code page, where you can add JavaScript code to do specific things before the simulation starts. And then there are the view elements.
View elements, meaning.
The visual stuff. Graphs, charts, interactive objects, all that.
So they're not just writing code, they're also designing the visual layout of the simulation.
Exactly. They're thinking about how learners will see and interact with the simulation.
It's like they're putting together a complex machine, understanding how each part works and how they all fit together.
That's a great analogy.
And to really solidify their understanding, they got to play around with existing simulations like the Ferris wheel and the harmonic oscillator.
Yep. They got to see how those concepts could be modeled and visualized using EjsS. It's like taking apart a clock to see how all the gears and springs work.
I love that analogy. It's about understanding how things work on a deeper level.
Absolutely. And then in the afternoon, they shifted their focus to EjsS views.
EjsS views. So that's all about the visual aspects of the simulations.
You got it. Making them not just functional, but beautiful.
Okay, so we're not just talking about making things work. We're talking about making them aesthetically pleasing, engaging.
Precisely. They learned how to use interface components like buttons, sliders, and text boxes to make the simulations more interactive.
So they're thinking about user experience, how to make the simulation easy and fun to use.
Exactly. And they explored how to use 2D and 3D shapes, creating objects that move and interact within the simulation.
So they're building these little virtual worlds for learners to play around in.
In a way, yeah. And they even learned how to use data tables to display numerical data in a clear and organized way.
It's amazing how much depth there is to this.
I know, right? It's not just about writing code. It's about design. It's about user experience. It's about data visualization.
That's whole art form.
It is. And by the end of day 3, they were creating simulations that weren't just functional. They were visually stunning.
I bet they were feeling pretty proud of themselves at that point.
Oh, yeah. So now they've got all the tools and knowledge they need to build these amazing simulations.
What did they do with all that on day 4?
Well, day 4 was all about pushing the boundaries, exploring those advanced techniques, and putting all their new knowledge into practice. Day 4, yeah, it was all about going deeper. They got into debugging.
Ah, debugging. The joy of hunting down those pesky errors in your code.
It can be frustrating, for sure, but oh, so satisfying when you finally figure it out.
It's like being a detective.
Totally.
Yeah.
And then they got into sound, like integrating sound into the simulations.
Oh, wow. So instead of just seeing a bouncing ball, you could also hear it.
Exactly. Like a nice, satisfying thud with every bounce.
Mm-hmm.
Makes it way more realistic.
Adds another dimension to the whole experience. What else did they cover?
Let's see. Oh, they even got into acquiring data from mobile devices.
Like smartphones and tablets?
Yep. So they could use real-time data in their simulations.
That's really cool. I can see how that would be useful for, like, a physics experiment.
Exactly. Imagine a simulation that uses the accelerometer in your phone to measure acceleration. Pretty neat, right?
That's wild. It's like blending the digital world with the real world. Do they do anything else with mobile devices?
Well, they also got into client-server communication.
Client-server communication. Now, that sounds complicated.
It is, a bit. But basically, it lets simulations interact with external data sources. Like imagine you're ordering food online.
Okay.
Your device, that's the client, sends a request to the restaurant's website, that's the server. The server processes your order and sends back a confirmation.
Got it. So in this case, the simulation would be the client, and it could send requests to a server to get information.
Exactly. You could create simulations that can access data from anywhere in the world, or even interact with other simulations.
Wow. That opens up a whole world of possibilities.
It does. Now remember, the goal wasn't to turn everyone into expert programmers in a day. It was about giving them a taste of what's possible and encouraging them to keep learning.
So kind of like sparking their curiosity and giving them the tools to explore further on their own.
Exactly. And then, in the afternoon, they got to put all their new skills into practice with some independent project work.
Oh, that's always fun. What kind of projects did they come up with?
All sorts of cool stuff. Some of them built simulations of a bungee jump.
A bungee jump. That's a good one.
Yeah, they could adjust things like the length of the cord and the jumper's weight to see how it affected the jump.
Sounds like a fun way to learn about physics.
It was. And another group created a thermal physics model.
Thermal physics, so like heat transfer and stuff.
Exactly. They could visualize how heat moves through different materials.
Pretty impressive stuff for just a 4-day workshop.
Right, and it shows what you can accomplish when you combine hands-on learning with, really passionate educators.
I agree. It's inspiring to see their dedication.
It is. So, big picture, do you think these interactive textbooks, do they have the potential to really transform education?
I think so, yeah. I mean,
Yeah.
they can make learning more engaging, more effective.
And more accessible, too, right?
Absolutely. Not everyone learns best by just reading a textbook. Some people need to see things in action to interact with the concepts.
Totally. And I think we're only just scratching the surface of what's possible.
I agree. I'm excited to see where this all goes.
Well, I think that's about it for our deep dive into interactive textbooks.
Yeah, we've covered a lot. From building simulations to the whole idea of open educational resources.
It's been fascinating. If you're interested in learning more, check out the OSP at EjsS website. You might discover a whole new world of learning.
And who knows, maybe you'll be inspired to create your own interactive learning experiences. Until next time.